Hey team, we are back. We have now finally fully moved on to chapter 10 of the CCNA-301 volume 1 book. And so chapter 10, it discusses rapid spanning tree or RSTP and Etherchannel configuration. So, the last session we had, we went over the optional spanning tree features. We went over Etherchannel, right? As it relates to spanning tree. We went over BPDU guard, and we also went over port fast from a theoretical standpoint, right? And so what we're going to do now is go in depth, talk about RSTP, right? The need, right, for why multiple spanning trees are exist, right? Why it's needed, right, within modern technologies, the different types of spanning trees and modes. Um, Going a little bit in depth about the bridge ID and system ID extension, right? So we're definitely going to go low level for a little bit. Um, Talk about how the switches use the priority and system ID extension when making a decision to elect the root switch or what have you, right? And then we're going to stop right there, right? We're going to take a little break, right? And then we're going to go ahead and dive in and um, discuss, everything that we've covered so far. We'll take a little break today. After that's done, then we're going to come back tomorrow with the rest of the chapter as regarding to RSTP. Then we'll go ahead and come that session after that, we'll go ahead and talk about Etherchannel. So I'm going to go ahead and split it up. So it'll be two sessions for RSTP. Then it'll be the following sessions after that regarding Etherchannel and how to actually configure it. Okay. All right. So let's go ahead and get started. All right. So, as always, has a great reminder. Always look at your OSI networking model terminology, right? And understand the difference to has a on your left your OSI networking model, right? And to your right, the TCP/IP networking stack, right? The TCP/IP network stack is actually what's installed and implemented on you guys' computers, right? So this is what you'll see. You go ahead and log into your PC, do some packet captures. You're looking at how your PC is built. This is how your PC operates, encapsulates data, puts it on the wire, gets going to go. Okay. Um, so yeah, so that's how that looks like. But let's go ahead and keep diving in. I just wanted to give you guys a quick reminder. It's very important to memorize this. If you guys are definitely going to be network engineers in the future, you have to memorize this to a T as it relates to all the theories that you're learning and also as it relates to compiling all the theories that you're learning and with troubleshooting. It is very important to remember that OSI model. Okay. So make sure you take a look at that whenever you get a chance, right? So with this new chapter, right, there's a couple of objectives, right, from that CCNA objective list that we need to go ahead and cover for the exam, right? So here's some of the objectives we need to cover, right? We need to make sure that we have a great understanding on, right? Um, it's covering 2.0, which is network access, and we have some child properties under network access, right? One is configure and verify layer 2 and layer 3 Etherchannel, right? um, of course, we're going to talk about LACP, right? Describe the need for and basic operations of rapid spanning tree, right? Per VLAN spanning tree. That's what PVST means, right? So rapid per VLAN spanning tree plus, right? Um, Spanning tree protocol and identify basic operations. Okay. All right. We also at 2.5.a, right? Understand the root port, right? What the root bridge is, primary and secondary, and other port names, right? 2.5.b, right? We're going to go over port states, right? As far as forwarding and blocking, right? And of course, 2.5.c, right? Port fast benefits. A lot of these things, from a theoretical standpoint, you guys already touched and already been learning about, but we're going to go ahead and do a review, right? Which is what this book is going to do in this chapter, but also, give you guys insight to some, key topics that you need to understand, new terminology that you need to understand, so you can be successful in understanding some of the questions that you will receive on the exam, right? So let's talk about RSTP for a second, right? So RSTP, right? With RSTP, right? Every switch now that that has Cisco iOS that's used in the modern day and age, right? And as of 2023, right? They are being shipped out from Cisco, right? From whatever vendor you buy it from, with RSTP has the default mode for spanning tree versus using the regular spanning tree mode. I know in the past, lab fun days, you guys would see if we do a show spanning tree, right? You guys would see the mode would by default would be IEEE, which stands for just doing the regular spanning tree mode, right? Now switches are now arriving to customers using with the default setting being RSTP with no configuration being required. Okay. Right. And so typically within an environment in this building, you guys can actually see the slideshow, right? Typically, right, if we have a two-tier, right, a two-tier deployment, right, two-tier architecture, right, we have our distribution switches and we have our access switches, okay? And we'll talk about, architecture, what have you, in a later chapter, right? But just follow me for now, right? Typically, right, since those distribution switches are the closest to the edge of the network, edge being, of course, getting to outside of the network, right? That boundary, that layer 3 boundary to leave the network. We want the exit points, right, to be the switches that are most close to the exit point, which would be those distribution switches, right? And those distribution switches, right, in a typical configuration would be the distribution switches, right? The access switch in your design would not be the root switch, or it should not, right? You can do whatever you want with, of course, configurations and what have you as engineers. It is recommended, right, because of course we learn the core theory about, right, spanning trees, that whenever we select our root switch, all the ports are available. They're in a forwarding state. So it's recommended that, of course, we need it's recommended that, of course, that root switch having all the ports being in a designated row, and of course, the state of those ports being a forwarding state, right, out of all of its ports, we want that to be assigned to a port, right, to a switch that's closer to that exit point, right, that edge of the network, right, that layer 3 device, right, and that's going to be these distribution switches, okay? So those are the best choices to be a root, right? We spoke about in the last chapter, you can configure spanning tree to operate. One switch can be the primary route and one can be the secondary, where they go ahead and assign different priorities to the primary and the secondary, right? They have all of that built in, and we'll take a look at that in our lab fun day tomorrow. Okay, so this is just how that looks like, right? But we'll examine a little bit more what this diagram is actually trying to show us, right? Because if we take a look at this, right, we see a few things, right? We have our two-tier topology, but what else do we see, right? We see a couple of trees here, right? But we also see an ether channel, right? We see an ether channel between both distribution switches so they can communicate, okay? So this is real fun stuff, and we're going to dig into this topology a lot during this chapter review, okay? So I spoke about it before, right? And I spoke about how there is a need for multiple spanning trees, right? For multiple spanning trees, multiple VLAN instances, right? And let's take a step back, right? What is a virtual LAN, right? Right? That virtual LAN is a local area network, right? That's configured virtually, right? If VLANs didn't exist, right, we would just have a switch that connects everything together, right, from a layer 2 perspective, right? Right? Without VLANs, they all are respective to each other, right? Now that we have virtual local area networks and we have the ability to add different virtual area networks, right, we can go ahead, right, and assign different ports to different virtual local area networks, right? Or VLANs, so to say, right? So with that, right, we can go ahead, right, and we can go ahead and manipulate our topology as we see fit, right? And what I mean by that is we may have one switch, right? And let me get my pencil. We may have one switch that's the root, right? I just circled switch 1, right? And switch one may be the root for the engineering team, right? Maybe they need to go out of a fiber link, right? Right. But switch two, right? A lot of users are plugged into and switch two, of course, it's plugged into a you know coax cable link, right? A little bit slower, but it gets the job done. They actually don't need high speeds, right? But that coax link is connected to switch two, right? And right, each switch in this topology, they have all VLANs. They have VLAN 1 and VLAN 2, right? But what if we want, right? We want the people, right, on VLAN 2 to be able to directly go straight to the coax, right? We're going to go ahead and put them in VLAN 2, right? But we need to make sure, right, because of the rules of spanning tree, we need to make sure the exit point is switch two from a layer two perspective. We can go ahead and set the gateway and what have you for, right, that next hop, right? But from a layer two perspective, we need to make sure traffic immediately goes out of switch two, right? So we can go ahead, right, for those that are in VLAN 2, say, hey, for VLAN 2 only, switch 2 is the root. But for VLAN 1, switch 1 is the root, right? So it's an amazing thing, right? And that's one thing that that I want you guys to understand for this exam is that you need to understand the purpose of multiple spanning tree, right? And there's a lot of benefits that we're going to go over, right? But the core theory that I was speaking about before, as far as not even having VLANs at all, right, is that before VLANs and what have you, we had something called a common spanning tree topology, meaning the entire switch topology shared one VLAN, right? One virtual local area network, right? And it was for everything. So it wasn't split up to maybe a sales virtual local area network or engineering social, virtual area network, virtual local area network. It was just one. It was a common spanning tree topology. And that's not very effective, right? It's not very effective because if we did have that, right, our users that maybe need to get out to go out the coax link versus the fiber link, right? They're not going to, right? It's going to take them, quite a bit of time to go ahead and get there and probably be overburdened because we also have users trying to get to the fiber link, right? The fiber link router, right? And so the traffic is not going to be load balanced properly, right? If everybody's plugged in switch three. So again, we have different, and what we see here, VLAN and VLAN 1 and VLAN 2, these are spanning tree instances, right? And with these different spanning tree instances, switch 3 can actually block on different interfaces for the betterment of each spanning tree instance or each VLAN, okay? So it's great for load balancing. It's great for identifying, optimal traffic flow, okay? So let's go ahead and keep going, right? And so here's some of the things we do need to go over, and I need you guys to understand, right? There's different types of standards and configuration options for spanning tree, right? And so let's start with one, right? We have STP, right? Regular spanning tree, right? And so the number of trees you can have, right, is one, right? Which is the common spanning tree, right? And so the original standard, of course, is 802.1D, okay? Right, next we have PVST plus, right? And so PVST plus, right, it's based off of spanning tree, right? You only can have one VLAN, okay? Um, right, one per VLAN, right? One instance per VLAN. So it's a per VLAN spanning tree, right? Versus the original spanning tree, just one common spanning tree, right? And of course, it's based off of 802.1D, right? And of course, if you wanted to configure it, you would change the mode to go to global configuration. You would put spanning tree mode, PVST, right? Now we go ahead and move over to RSTP, right? It's based on just the RSTP, right? Standard, right? That IEEE standard being 802.1W, right? The regular RSTP, right, has only one common spanning tree, okay? Versus now, right, we have an even more upgraded rapid per VLAN spanning tree plus, right? It's based off of RSTP, right? And it has one instance per VLAN, okay? And of course, the IEEE standard is 802.1W, right? And the configuration parameter, right? If you were going to global configuration mode, if you wanted to enable it, would be rapid-PVST. There's another mode, right? That of course you guys need to be made aware of, right? Is multiple spanning tree protocol, right? MSTP, right? It is based off of rapid spanning tree, right? You can have actually one or more spanning tree. Okay, so this column, right, it's letting us know how many number of trees we can have. All right, and so the actual EEE standard for MSTP is 802.1S. All right, and it's MST, right? And so the little excerpt that I need you guys to understand, because this is a key topic you need to know for the exam, is that MSTP, right, allows the definition of has many instances, right, multiple spanning tree instances or MSTIs, has chosen by the network designer, but not require one per VLAN. Okay. All right. And so here's a screenshot excerpt, right, from the text, right? All credit go to Cisco Press, of what that looks like configuring the different spanning tree modes, right? So you can do MST, you can do PVST, and you can do rapid PVST. All right, simple enough. And we'll go into detail how that looks like, because I really want to give you guys insight of what an instant looks like and what a VLAN looks like, right? And how to tell the difference, because you can get confused between the two terminologies. Sometimes it means the same in context and sometimes it doesn't. So we'll go over that in lab day. All right, now let's move on. All right, the bridge ID and the system ID extension, right? And so what this is, right? The switches, and we went over this before, right? A switch's bridge ID or BID, right, was formed by combining, right, the switch's 2-byte priority and its 6-byte MAC address, what we see on the screen, right? Right? These revised rules, right? And again, the revised rules, right, divide the original priority field into two separate fields, right? As we see, of course, here, right? Right? A 4-bit priority field and a 12-bit subfield called the system ID extension, which represents the VLAN ID. Okay, so let's take a look at this, right? So we have that priority, right? We have that priority right there, but we also have the system ID extension where we can go ahead and see right here, right? And that's a total of, right, of 16 bits, right? And of course a total of 2 bytes, right? And so this is how this bridge ID looks like. So we have that first part, and then the rest of the 6 bytes, right, is the system ID extension, the MAC address of the device. Okay. Okay. And so, and this is a key topic that we need to go ahead and go over, and I want people to understand is the switch actually lets you configure the bridge ID, but only for the priority part, right? You cannot manipulate the system ID. You can only change the priority number, right? Which are multiples of 4096, starting at 0 and then going up each 4096. So it'd be 0, 4096, and 4096 times 2, and so on and so on and so on. Okay. And so, they just goes up by 4096, right? And so that is what you can actually change in global configuration mode by putting in the command spanning tree VLAN 1 priority. And again, you'll go in increments of 4096, right? But, right, there's things that we need to go ahead and consider. With configuring, right, the priority number, right, we need to make sure that we're doing it, right, in increments of 4096, right? You can use any number, but it's better to go ahead and do so because the different commands like setting the root, the primary root, and of course the secondary. So these are just things, of course, you want to go ahead and configure. And I think the device, if I'm not mistaken, it'll give you a little warning sign if you go outside of doing in increments of 4096. So I think the increments would be, if I'm not mistaken, and I would actually save this, right, for you, of course, your own network engineering journeys, is this sheet, right? And I actually have this on my desk, right, in the office, and it actually shows me, hey, we start at 0, 4096, 8192, and it goes all the way up, right? Goes all the way up to 65, 535, right? It requires a decimal in that in that uh in that series. So from all the way from 0 all the way to 65, 535. All right, multiples of 4096. Okay. All right. So, all right. And just has a quick excerpt, right? That I want you guys to understand. I know I was talking about using the spanning tree root primary command and the spanning tree secondary command. What that actually does is it goes ahead, whenever you configure the primary, it's going to set the priority to 24, right? It's going to set it to, let's go back to it. It's going to set it to 24, right? 24, 576, right? And we see that here, right? Or, right? Because this is not a hard number. It's going to either do that or it is going to set it to 4096 less than the current root's priority. Okay, so if the switch received BPDUs, right, and it has the root ID, right, it has locked in what that priority is for the root, and you configure on the current switch that read it, hey, this is, maybe the root is, if we go ahead and erase this, maybe the root is 16384, but you go on that switch and say, hey, I want to go ahead and configure this to be the new root, right? And I'm going to set this as primary. What it's going to do is the switch is going to read that and the CPU is going to say, hey, perfect. I just set it to 4096 less than what the current root ID is, root priority is. It's going to set it to 4096 less. Okay? All right. So let's go ahead and erase this, all right? And hopefully that makes sense. I'm trying to keep it as simple as possible, okay? All right. And of course, the secondary command is going to do the same thing, right? If we do the spanning tree VLAN, right? The whatever the number of the VLAN is, and we set it to secondary, it's going to do the same thing. It's going to make it 4096 more than the current primary, right? Or the current root. All right. Okay. So how do switches use the priority and system ID extension, right? And so if we go ahead and take a look at this, right? We see the configured priority, right? At the top, right? So it's configured at 1000, right? And and it had, of course, the decimal value is such, right? We'll say it's 32,768, okay? Right? In 16-bit form, right? And then what the switch does, it looks at it looks at the system ID, right? The system extension, right? And we have 12 zeros, right? So if we move down, right, we go ahead and look at the VLAN ID, right? We take a look at that, and it gives us what the decimal 9 is in binary, right? And so putting all this together, we go to the bottom and we see the 16-bit priority all together, right? Right? And so what does this show us, right? What this shows us is just the sum of two numbers, right? Both in binary and decimal, right? And what it shows us here is what? 1. The output shows us, right? This is VLAN 9, right? It shows the root switch has been configured with the spanning tree VLAN 9 priority 24576, right? Command, right? And the local switch, the switch on which the command was gathered, has been configured with the spanning tree VLAN 9 priority 32768 command. Okay, so again, the root switch has been configured with the spanning tree VLAN 9 24576, right? But the local switch has a spanning tree priority set to spanning tree VLAN 9 priority 32768, right? Okay, and we'll take a look at this a little bit more in detail of how this looks within Lab Fun Day, right? But keep this in your mind, see how it looks, right? Because we're gonna do the math tomorrow and we'll have a little bit of fun so you guys will see how it looks, okay? All right, you guys have a great day.